Today we're going to talk about combining like terms and the distributive property. Some definitions I would like you to write down are variable. The variable is a symbol used to represent a quantity that can change. A symbol is usually a letter for us. So a constant is a value that does not change. It also has no variable, therefore it doesn't change. It is constant. The coefficient is the number being multiplied by the variable. We also call it the numerical factor of a term. A term are numbers or variables or products of numbers and variables separated by a plus or minus sign. So you'll see here in the expression that I have laid out, we've got 6a squared plus 5ab plus 3b, take away 12. These numbers, 6, 5, and 3, are called our coefficients. Those are the numbers that are being multiplied by the variable. They're the numerical factor of the variable. Well, what are our variables? They are a squared, ab, and b. 12 is called our constant. It will always be 12. It doesn't change in this problem. Our terms are separated by these plus and minus signs. We have 4 terms. 6a squared is a term, 5ab is a term, 3b is a term, 12 is also a term. The distributive property. This distributive property says for every real number a, b, and c, a times the quantity of b plus c will equal a times b plus a times c. So what that means is we're multiplying a times the both items that are inside the parentheses. We're multiplying a times b and a times c. And this is what our product will look like. We can also do that with subtraction inside our parentheses. We're doing a times b minus a times c. Some numerical examples of using the distributive property will be as so. 5 times the quantity of 20 plus 6. Well, that means 5 times 20 plus 5 times 6. I've also got 9 times the quantity of 30 minus 2. Well, that means 9 times 30, take away 9 times 2. That's what it means. We could follow up and actually use order of operations to solve and find the answer, but we're not going to do that today. I just wanted to show you some examples of the distributive property. We also use the distributive property when we use mental math. If I have a problem that says 34 times 102, I can break 102 apart. I can break it into 100 plus 2, because that put together, that makes 102. So I can rewrite the problem as 34 times 100 plus 2 in parentheses. Using the distributive property, that means 34 times 100 plus 34 times 2. 34 times 100 is 3,400. 34 times 2, 68. I can add those together and get 3,468 as my answer. Well, I can also do that using subtraction. I've got 15 times 29. Well, what's an easy number close to 29 that I can use for the distributive property? I can use the number 30. Well, how do I get 29 from 30? I take away 1. So I'm going to rewrite this problem so that it looks like this. 15 times the quantity of 30 minus 1. I'm going to multiply 15 times 30 and subtract 15 times 1. 15 times 30 is 450. And 15 times 1 is just 15. When I subtract them, I get 435 as my answer. I took a problem that would have taken me a lot of math work. I might have made a simple error, and I made it into a problem I could quickly do and quickly understand with very little errors. Here we've got some simplifying expression examples. I'm going to use the distributive property to put this expression in simpler terms with the least amount of terms. So number 1, I have 2 times the quantity of 5x plus 3. Well, using the distributive property, that means 2 times 5x plus 2 times 3. 2 times 5x, it's like having 2 groups of 5x's. Altogether, I would have 10 x's. 2 times 3 is 6. So my final answer is 10x plus 6. Over here, I've got 3 times the quantity of 3 plus 7t. So using the distributive property, 3 times 3 and 3 times 7x. That would be what I would write down. Then I have 3 times 3 is 9. I know that off the top of my head. And then 3 times 7t. That's like having 3 groups of 7t. So altogether, I would have 21 t's. What I'll explain to you in a little bit is when we write our final answer, we want our terms with our variables to come in front of the constant. That's just the commutative property of addition that I'm using. So I'm going to rearrange these 2 terms, and I'm going to have my final answer that read 21t plus 9. Number 3, 1/2 times the quantity of 2m plus 4. So I'm taking half of 2m. Well, half of 2 is just 1. I'm just going to write that with the letter m. That's already understood that there's a 1m there. That's because we have 1m, but I just don't need to write the 1. And then half of 4 is 2. So my final answer is m plus 2. And then our last example, I've got the 7 over here on the right side. Well, even though it's on the right side, I still use the distributive property to help me solve. So I'm going to multiply 3x times 7 plus 2 times 7. 3x plus 7 is 21 x's. That's 7 groups of 3 x's, altogether 21 x's, and then 2 times 7 is 14, and that's my final answer. Let me review what like terms are with you. Like terms have exactly the same variable factors. The variable factor, not the numerical factor, but the variable factor, has to be exactly the same in each term. For example, 3x squared and 4x squared are like terms. They have exactly the same variable factor. Same here, 6xy and negative 5xy are like terms. Their coefficients do not have to be the same, but the variables have to be exactly the same. Here are some examples that are not like terms. 4x and 2y. One has an x, one has a y. They are not like terms. 7a squared and 3a. Well, they are similar, but they're not exactly the same variable factors. One has an a squared, and one is just plain old a. These are not like terms. And then we've got 2xyz and 10yz. Well, this one has an x in it, this one does not, therefore they are not like terms. VIC number 1. VIC stands for a very important concept. All constants are like terms. That's very important. So if I have a problem that has me combining a 4 and 10, I can, because they're constant. They are like terms. 22 and 109, those would be like terms. Negative 13 and positive 13, those are like terms. If I had to combine them, I could. VIC number 2. To add or subtract terms, they must be like terms. So now I'm going to start combining and simplifying my expressions using the distributive property. So if I have a situation like this, 15x plus 12x, well, using the distributive property, I can remove an x. I can take it out and pull it to the side. And left over, I've got 15 plus 12. Well, I know what 15 plus 12 is. That's 27. Well, this statement is telling me that I've got 27 x's. I had 15 x's over here, I've got 12 over there, and when I put them together, I've got 27 altogether. I've just combined my like terms, and they are like terms because they both have an x. Here, I've got 3x squared plus 5x squared. If I pull out or distribute out an x squared, what do I have? I've got 3 plus 5. Well, 3 plus 5 is 8. So that means I've got 8x squared, or 8x squared. Here, I've got 3 terms. 2z plus 4z minus 3z. Well, if I use the distributive property and I pull out my z's, I've got 2 plus 4, take away 3. Using order of operations, I would like to do my addition because it comes first before subtraction, because I'm reading this from left to right. So 2 plus 4 is 6, and then I bring down what's left. 6 minus 3 is 3. So I've got 3 z's when I simplify this problem. Number 4, 7y squared plus 6y. This cannot be combined. This problem is already in its simplest form. It is already simplified. These two are not like terms, so I'm done. Fic number 3. Use shapes or colors to help you identify like terms. You must include the plus or minus sign in front of the term when identifying it. So as you can see, I've identified all my terms. I've got 3x plus 9 plus 2x minus 8. Well, here are my 2 terms that include the variable x in them. I'm going to circle them. I'm going to use colors or shapes, similar shapes to identify them as like terms. Here I'm including a plus sign that came in front of the 2x because that represents a positive 2x. Here on my very first term, I don't have any symbol in front of it. Therefore, it's already understood that it's a positive number. So I've got positive 3x plus 2x. Altogether, I've got 5x. Then I have a positive 9, and I'm taking away 8. Positive 9 take away 8, well, that's just 1 left over. This whole thing is my final answer. Over here, I've got 6a squared plus 4d plus 12a squared minus 2d. My like terms are the terms that have a squared in them, and then my other like terms are the terms that have d's in them. When I identify the like terms, I always include the symbol that comes before the term, as you can see. That just helps me know whether I'm adding or subtracting. So I've got 6a squared plus 12a squared. Altogether, that gives me 18a squareds, or 18a squared. I've got a positive 4d, take away 2d. Altogether, that gives me 2d. So all in all, I've got 18a squared plus 2d. That's the simplest I can write this expression. So that's my final answer. Fic number 4. When writing your simplified expression, rewrite terms in alphabetical order. That's what I said before. The term that has the variable with the highest power goes first, and constants come last in the simplified expression. So here we go. I've got 21b plus 10a, take away 8a, minus 6b. Well, here, my like terms are together in the middle. I've got a positive 10a minus 8a. Those are like terms. And a comes before b in the alphabet, so I'm going to go ahead and simplify that first. Positive 10a, take away 8a's, leaves me with 2a's. Then I can concentrate on my b's. I've got positive 21b's. Remember, I know it's positive because it has no symbol in front of it, so it's automatically a positive 21b. Take away 6b. 21, take away 6, I'm left with a positive 15. My final answer is 2a plus 15b. Here, I've got 3x plus 7x squared plus 6x minus 2x squared. My like terms are my positive 7x squared minus 2x squared. I'm going to concentrate on that first because when I write my answer, I'm going to write the term that has the highest power in front. So since x squared is a higher power than x by itself, that's going to come first in my answer. So I've got 5x squared when I take 7x and I subtract 2x squared from it. And then lastly, 3x plus 6x, altogether I've got 9x. So my final answer, 5x squared plus 9x, and I'm done. I've got one last Vic for you. If a variable does not have a visible coefficient, it's understood that the coefficient is 1. And again, this is what I said before. So I'm going to simplify this expression, 5q plus x minus 3q plus 7x. So if you take a look at it, I've got q's and x's. Well, what comes first in the alphabet? Q comes before x. And then here, I've got an x by itself. Well, that's understood that it's just 1x. There's 1x there. So I'm going to concentrate on my q's first. 5q, take away 3q's, left me with 2q's. Then I've got positive 1x plus 7 more x's. So altogether, I've got 8 x's. And then, finally, I've got x squared. There's not a coefficient in front of this, so it's understood that there's 1x squared there. Plus 3y squared plus 2x squared minus 2y squared. Well, I've got some x squareds and some y squareds. So what comes first in the alphabet? X comes before y. They both are being squared, so I really don't have to worry about the power and the exponent at this point in terms of order. I know I'm going to put my x's in front of the y's. So I've got 1x squared plus 2x squareds. That leaves me with 3x squareds. I've got a positive 3y squared. I'm taking away 2y squareds from it. That leaves me with 1y squared. Do I need to write this 1 in front of the y squared? No, because it's already understood that that is 1y squared. I don't need to make more work for myself. I don't need to add extra numbers. I can just leave it like this, 3x squared plus y squared, and that's my final answer. This is in the simplest form.